What if I told you that humans once landed on a planet where the air can crush metal, the heat can melt lead, and the sky glows in a strange yellow light? And we did it decades ago, not with modern computers or touch screens, but with Cold War-era machines built by the Soviet Union. These missions went to Venus, Earth's closest twin in size, and what they found there shocked everyone. When most people think about space exploration, they picture the moon or Mars. Venus rarely comes up. That's strange, because Venus is right next door. You can see it with your own eyes in the evening sky, shining brighter than almost anything else. For a long time, scientists wondered if Venus might be like Earth, same size, similar mass, maybe oceans, maybe clouds full of rain. Some even imagined jungles or shallow seas hiding beneath those thick clouds. The Soviets were the first to take this mystery seriously. Starting in the early space age, they sent probe after probe toward Venus. Many failed. Some burned up, others lost contact, but a few actually made it all the way down to the surface. That alone is incredible. Venus is brutal. The heat is hotter than a pizza oven left on full blast. The air pressure is like being deep under the ocean. Most machines die there in minutes. Yet some of those Soviet landers survived long enough to send back data and even images. Real pictures from the surface of Venus, not drawings, not guesses. Actual photos from another world. What they showed was not a paradise. Venus turned out to be a warning. The sky was thick and heavy. The light looked dim and orange, like a never-ending stormy sunset. The ground was rocky and broken, with flat stones that looked almost placed by hand. There was no water, no plants, no sign of life, just heat, pressure, and silence. This matters more than it sounds. Venus and Earth started out very similar. Same neighborhood, same basic ingredients, but they took very different paths. Earth became a world full of life. Venus became a world that can destroy almost anything we send there. Understanding why that happened helps us understand our own planet better. It also helps us think about the future, about climate, about how fragile a living world can be. The Soviet missions also proved something important about humanity. Even with limited tools, fear, and competition, we pushed beyond our planet and touched another world. We learned that space does not care about our hopes. It only follows its own rules. In the next part, we'll look closer at how the Soviets managed to land on Venus at all, and why so many missions failed before a few finally succeeded. Venus sounds simple. It's closer to Earth than Mars, and it shows up bright in the sky all the time. But Venus is tricky. Reaching it is like trying to land a paper airplane inside a volcano. Early Soviet missions learned this the hard way. The first probes were hopeful guesses. Engineers knew Venus was hot, but they did not know how hot. They knew the clouds were thick, but they did not know what they were made of. Some probes lost radio contact on the way. Others were crushed before they could send anything useful. Each failure brought a hard lesson. Slowly, piece by piece, the Soviets began to understand what kind of monster Venus really was. The real breakthrough came with a series of missions called Venera. These were not just flybys. They were designed to fall through the clouds and survive on the surface, even if only for a short time. To do that, the landers had to be built like tanks. Thick metal shells, tiny windows, no moving parts that could easily melt or snap. As the probes dropped through Venus's atmosphere, strange things happened. The air got denser and denser. It was not like falling through sky. It was more like sinking through liquid. Temperatures climbed fast. Electronics began to fail. Many probes died before they ever reached the ground. But then, in the 1970s, something amazing happened. Venera 7 made it to the surface and sent back a signal. It was weak. It barely lasted. But it was proof. Humans had touched Venus. Later missions did even better. Venera 9 and 10 sent back the first images. Picture this moment. Engineers sitting in a room on Earth, waiting for lines of data to turn into an image from a planet no human had ever seen up close. When the picture appeared, it was rough and grainy, but unmistakable. Rocks, shadows, a horizon. The Soviets did not stop there. They kept improving the design. Venera 13 and 14 lasted longer. They sent color images. They measured the soil. They recorded sounds, though the wind was faint and heavy, not like Earth's breeze. One of the most surprising things was how calm the surface seemed. From space, Venus looks violent, wrapped in raging clouds. On the ground, it was quiet. No storms, no rain, just a crushing stillness. The real danger was invisible. Heat and pressure doing their work slowly, bending metal, frying circuits. These missions mattered because they showed that planning alone is not enough. Space teaches through failure. Every broken probe carried information. Every short signal mattered. The Soviets accepted that some missions would die, and they kept going anyway. By the time the last Venera landers fell silent, they had changed how we see Venus forever. It was no longer a mystery hidden behind clouds. It was a real place, harsh and unforgiving, and very, very different from Earth. In the next part, we'll talk about what those landers actually found on the surface, and why the pictures from Venus still unsettle scientists today. When the Soviet landers finally reached the surface, the big question was simple. What does Venus really look like when you're standing on it? The answer was both familiar and deeply unsettling. The first images showed a rocky ground, scattered with flat stones and broken slabs. At first glance, it almost looked like a desert on Earth. But the longer scientists stared at the photos, the stranger it felt. The rocks did not look eroded by water. There were no smooth river shapes. Everything looked baked, cracked, and aged by heat instead of rain. The sky was not blue. It was a thick yellow-orange glow, like sunlight forced through dirty glass. Shadows were soft and blurred. That told scientists the clouds above were dense and spread light in every direction. There was no clear sun in the sky, just a dim brightness pressing down from above. The landers also tested the soil. It turned out to be dry and hard, similar to volcanic rock. This was a big clue. Venus had likely been shaped by massive volcanic activity. Some scientists still think parts of Venus might have active volcanoes today. If so, they would not look like Earth's fiery mountains. They would ooze slowly under crushing pressure, reshaping the planet in silence. One experiment even dropped a metal arm onto the ground to test how strong the surface was. It did not sink. That meant no soft mud, no hidden oceans under the dust, just solid, hostile terrain. Temperature readings were shocking, even by pessimistic guesses. Hotter than a kitchen oven on full power, hot enough to weaken steel over time. And the pressure was worse. Imagine standing under the weight of a deep ocean, but without water. That was the surface of Venus, every second, everywhere. There was also the air itself, mostly carbon dioxide, with clouds made of acid. Not the kind that burns instantly, but the kind that slowly eats away at materials. Breathing it would be impossible. Even standing there would crush a human body flat. What made this discovery so important was not just how extreme Venus was, but how ordinary it looked at first glance. Rocks, ground, a horizon. If you remove the heat and pressure, it could almost pass for a lifeless place on Earth. That similarity made the differences hit harder. Venus was once called Earth's sister planet. Now it looked more like a warning left behind by the universe. Same size, similar beginning, totally different ending. These findings forced scientists to rethink how planets change over time. Venus likely had water long ago, maybe even oceans, but something pushed it too far. The heat trapped itself, the air thickened. The planet crossed a line and could not come back. In the next part, we'll explore what went wrong on Venus, and why its story matters so much for Earth's future and the search for life beyond our planet. To understand what went wrong on Venus, you have to imagine the planet long before the Soviet landers ever touched it. Billions of years ago, Venus may have looked calm. It sat in the same neighborhood as Earth. It had volcanoes, rock, and maybe even shallow oceans. From space, it might have looked like a slightly warmer version of our own world. The problem was heat. Venus is closer to the sun, not by a huge amount, but enough to matter. As the planet warmed, water began to evaporate into the air. Water vapor is powerful. It traps heat. The warmer Venus got, the more water vapor filled the sky, and the more heat stayed locked in. This created a loop that kept feeding itself. At some point, Venus crossed a point of no return. The oceans, if they existed, boiled away. Sunlight broke the water apart high in the atmosphere. The lighter part escaped into space. What remained was a planet that could never cool down again. Without water, something else took over. Carbon dioxide built up in the air. On Earth, this gas moves in a balance between air, oceans, rocks, and living things. On Venus, that balance collapsed. Carbon dioxide piled up, trapping even more heat. The planet turned into a pressure cooker that never stopped cooking. This is why Venus matters so much to us. It shows how small changes can grow into massive outcomes. Earth also has carbon dioxide. Earth also warms. The difference is that Earth has oceans, plants, and life that help keep things in check. Venus lost that safety net. The Soviet discoveries gave weight to these ideas. Venus was not just